Let's go. Next session, learning Rust live here. Pretty stoked. Yeah, we're on the third chapter here, so kept it a chapter a session each time. I don't know if that will necessarily be the case tonight, but it should be good either way. Probably gonna start with like a bit of a review here from the previous session, but we'll get into that in a few minutes. Yeah, it is hot as hell up here down here in Texas. Yeah, the lab is definitely hotter than normal, so I'm just trapped in here in this streaming closet, just me and Rust. So there's nowhere to go. There's nothing to do. Yeah, if you don't know where like the notes or the repo is, anything like that, link to that. Yeah, here it is. So learning Rust live, that's the repo. This has my notes on here right now, broken up in these different sessions. So yeah, I mean, something I'm really trying to do since this is Rust contains a lot of dense information that is new to me. Because I mainly come from JavaScript, mainly come from Python. So there's going to be a lot of concepts. There's a lot of keywords. There's too many things to really keep in my working memory. So, I mean, you know, that's why I'm taking notes here. Trying to make them clear, succinct, using ChatGPT to help me with them. And yeah, my flow is probably going to be like reading through something once, twice, and kind of making notes and then moving on. Just so I have, you know, I guess 2 passes at it and some kind of breadcrumb to leave behind. So that's going to be the workflow here. I mean, yeah, as we get further in and like get into some of the real projects, this will probably be more interactive. But right now we're still like trudging through the fundamentals, which is where a lot of people get caught up, right? It's where I did in the past. I had actually tried to learn Rust about 1.5 years ago, and it didn't go so well. Got probably 6 or 7 chapters in, was doing the projects. At some point, I looked back and I was like, I don't remember any of the stuff that I did. Fundamentals. Yeah. It's an ironic name, because fundamentals are never really fun. But you gotta get through them to get to the fun stuff, I guess. But yeah, so this is chapter 3, common programming concepts. So this is, I guess, gonna be kind of the most dense index of new concepts. So I'm gonna be taking it paragraph by paragraph. But yeah, we can look back at, go through last week's notes. I can run, this is the project here, the guessing game. First project. Let's run this. See. Cargo run. This will build it, run it. Guess the number. I don't know. Too small. Okay. We see that it does error handling when I enter nothing. That's cool. Before I was printing out the secret number, so I don't actually know what it is. But I guess that's the point. But yeah, still works, still runs. You would hope so with Rust. And yeah, we'll probably be stepping through a lot of this code again through the notes. So I'll pull these notes up. So session 2, programming the guessing game. Before this, you kind of start with nothing. You're just saying hello world, learning a little bit about cargo. Yeah, but here's where we're actually putting down the first code. So printing some lines, setting aside a string, using the standard library and the IO library to read from the command line, read inputs. Yeah, let's look through this. This line captures user input, expects a result value, and handles any potential error. I see. Mute guess. Okay, so this was, yeah, I remember we were reassigning guess. Oops. Right here, since it was mutable by reference. That's what the ampersand symbol means. I remember that. So mutability. So we know that you need to say if your variables are going to change or not with mute. We've got this method for string. Captures user input. Yeah, okay, so this is where we got into result types. And this was maybe one of the bigger concepts of last time. Yeah, so we know that like essentially every method that gets called will have a result value, which will either be like, yeah, an okay or an error. So result is an enum, a type that can be in multiple states. I think that's all we know about enums right now. Result states or variants are okay and error. Okay is successful, error is a failure. And the result types, they encode the error handling information. So that's interesting. Obviously I wrote this down last time, but that kind of makes this make more sense. The fact that it can be in multiple states. So like any library can use an enum and this result type to encode their own error into it, I guess. Yeah. Oh, one other thing on result values, I started watching, I forgot, Paul did, from Mutiny Wallet, did a workshop a while ago. When was this? 3 months ago for Pleb Lab. Kind of a basic Rust workshop. I started this today. It was really good. I actually missed it in person. Yeah, I want to put this down. I'll put this down as a resource because this was good. He talks, so far what I've been through in the video, he talks about the result type a little bit and kind of shows you that it's something you're going to be dealing with a lot. So, you know, we want to give it the proper focus. Resources. Write that down because that's something we learned about last week. And then what is it? Next workshop. Sweet. Okay, so result type, we get an okay or an error, we gotta handle it. I guess that's what to keep in mind for the moment. Adding crates, this is pretty easy, just kind of defining a name and a version in the cargo.toml. Where do we do that? That's hello cargo. So yeah, like we did it here at the Rand library. That was pretty easy. Ensuring reproducible builds. We'll probably get in this later. Or, I mean, we don't need to revisit this right now, at least. Cargo update, updating packages, Rust analyzer, Rand crate. Okay, this is when we use our first crate, our first kind of library to get a random number. So we learned that this is kind of how you call methods, this double colon, and this is how we import rand RNG, standard CMP ordering. Kind of digging in here in the import, but you could also just put standard, right? You could say use standard, and we could kind of define this when we're actually calling it. So that was one good thing I learned from Paul. Learned about match, essentially a switch statement. Uses arrow syntax. Here we use an ordering method to detect if it's less or greater or equal. Guess.cmp. Yeah, I don't remember. Secret number. Okay, here's some result handling. What was I looking at though? CMP. This method returns an ordering between self and other. Oh, okay. So we're matching on the result of this method. Okay, that is still a little weird looking back on it, but makes sense at least. And this is being passed by reference, secret number. Ordering, good ordering, no. Touch on shadowing. Create a variable guest. So Rust allows variable shadowing. This allows us to reuse the variable name guest without needing to create new unique variables. Okay. Variable shadowing is often used for type conversion. More details in chapter 3. Okay, well that's what we're going to learn about tonight then. Trim.parse. Yeah, there's a lot in here. Loop, type annotation. So we're going to get more into this. .trim.parse. Where do we use this again? Returns a string slice with the leading and trailing white space removed. Oh yeah, this just removes white space. Parses this string slice into another type. Okay. The parse method converts a string to another type. Okay, simple enough. Loop. This was pretty obvious how this works. It's just I guess it's a keyword. And then we're able to continue. So I guess we could do a break or a continue, kind of like Python. Oh yeah, we have a break right here. I see, so this is a continue on the error for guess. That's where we saw the error handling right here. Threw an error, but let the user continue, didn't crash the whole program. This is loop, know about match, CMP ordering. Yeah, more about the result type. Interesting. Print line. So here we're passing error as E. I guess, I don't know, that's what I would usually want to do. And then printing it, yeah. If parsing fails, parse returns an error variant. Error underscores a wildcard matching any error value. Okay. So that was session 2. A few pretty big concepts there that still definitely going to come up. But here here we are in session 3. So I'm going to go up to the book here. Yeah, let's get into it. And I've got my ChatGPT prompt right here ready. Okay. This chapter covers concepts that appear in every programming language. Specifically, you'll learn about variables, basic types, functions, comments, control flow. Okay, what is this? Rust language has a set of keywords that are reserved for use by the language only. Much as in other languages, keep in mind that you cannot use these words as names of variables or functions. Okay, that's normal. Right? So, variables and mutability. We know a little bit about mutability, a little bit about variables. So by default, variables are immutable, can't be changed. This is one of the many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you'll still have the option to make your variables mutable. Okay. So we're going to go through 2 scenarios. So, my camera fell down. Screw it. Camera stand broke. Okay, show goes on. Oh, it's not the first time that's happened. What's wrong with this thing? All right. Let's see, back to variables here. So Rust wants us to keep things immutable, seems like. That's safer. I mean, you know, it's more economical, but we can opt out of it. So example here, let x equal 5, x equals 6, and it errors. This example shows how the compiler helps you find errors in your programs. Compiler errors can be frustrating, blah, blah, blah. Experienced rustaceans cannot assign twice to immutable variable x. So that's a pretty easy error. Rust doesn't always have easy errors like that, but that one makes sense. This whole first section right here, I don't even feel like I need to take notes on this. I get this basic concept of mutability and immutability already. So instead, when we change it to a mute, we're able to change it. It compiles. constants, we have constants too. We have let and const, just like JavaScript. That makes sense. So constants are boundary name. They're not allowed to change. You aren't allowed to use mute with constants. They're always immutable. Constants can be declared in any scope. Okay. Here's an example of a constant, 3 hours and seconds. That's a cool example because they're showing you can do what would you call this? Like an operation. It's just going to be a constant, the result of that operation. So yeah, constants valid for the entire time a program runs within the scope in which they are declared. Okay. Okay. Yeah, man, this isn't that useful either, but I'll go ahead and put this down. Because I guess it's like good consideration that, okay, we should make consts whenever we know that something doesn't need to change. Okay, moving through this a bit faster than I thought already. We'll see here, shadowing now. So we talked about shadowing. In the guessing game, you can declare a new variable with the same name as a previous variable. Restation, say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any issues of the variable name to itself until either it itself is shadowed or the scope ends. Scope ends. Okay, so that's interesting. So now I'm kind of realizing that this is something that you do to carry a variable into like a lower scope, a child scope, like a function. And then use it, just kind of use it and lose it. So we can shadow the variable by using the same variable's name and repeating the use of the let keyword as follows. Interesting. So you can essentially, going back to this first exercise where they say, oh, x equals 6, even though it's not immutable, you can do this, but the only way that it'll allow you to do this is through shadowing, where you're essentially just making an updated copy that overwrites, in the current scope it's in, overwrites the x. And then I guess we see here we're going into a lower scope even. I've never seen just a straight up curly block like that, but even a lower scope and changing x again. Yeah, so the inner scope is 12. Value of x is 6. Okay. That was a good little bit. Let's take this chunk. Add this on my prompt. It's cool to try and like summarize something myself and then see how ChatGPT does it differently. So in Rust, we declare a new variable with the same name as the previous one. This is not a shadowing. First variable is shadowed by the second. The second variable takes precedence until it is shadowed or the scope ends. That's a pretty good summary. Copy all this. Shadowing. Okay. Cool. Put these in the bullet points though. With a name like shadowing, I thought this would be a harder concept. Sounds intimidating, you know? Okay. So that's our shadowing basic. Okay. Shadowing is different than mute, because we'll get a compile time error if we accidentally try to reassign to this variable without using a let keyword. By using a let, we can perform a few transformations on a value. Okay, we know that. You're effectively creating a new variable when we use the let keyword again. Seems, yeah, like a bit of a shortcut. Probably not a problem if you're just passing to a child scope for a second, but maybe becomes a problem if you do it all throughout your programs. Okay. For example, say our program asks the user to show how many spaces they want between some text by inputting some characters. Then we want to store that input as a number. Okay, I see. So we could have, in this example, we're storing the number of spaces. That's kind of a weird example, but I guess either way we can shadow it. So maybe, like, you could imagine maybe at the top level, the global scope, we would just store it. And then maybe we'd need to return length in some child scope function, and we could do that instead of, yeah, making it mutable and reassigning it. Oh, okay, and then we're not allowed to mutate a variable's type. That's a good little bullet point for me to have. So, yeah, let's get some for this section. Make this a code block. Okay, sweet. Makes sense, but yeah, that's still hitting me that we can't change types with mutation. So I can already foresee that there's going to be lots of like type workarounds depending on what we need to do with our variables. But cool, that completes the variables section here. Update that. Variables and mutability. Let's get into data types. So some of this we already know. We've worked with like some unsigned integers and stuff like that. Let's see what we get into though. So look at some data types. Keep in mind that Rust is a statically typed language, which means that it must know the types of all variables at compile time. Okay, that's expected. In cases when many types are possible, such as when we converted a string to a numeric type using parse, we must add type annotation like this. If we don't add the unsigned 32 type annotation shown in the preceding code, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. I see. I do remember that from before. Could it not infer? We were talking about inferring types that you want to. Tidwell is telling me want to lean on the type inference in Rust Analyzer as much as I can. We can go back to our program here right now, actually. Inside 32. Yeah, double click to insert. So it does infer it for me. I guess that's good. Hopefully, Rust Analyzer will save me from too many of these troubles. Call this section type errors, I guess. Let's grab this error message. Two subsets of data types are scalar and compound. I still don't really know what that means. That's ChatGPT. Can you explain this more? Scalar type in Rust represents a single value. Okay. I think we're gonna get into this. This is a good summary, though. So these are probably the other data types we're about to be introduced to. Let's see. Scalar types, integers, floating point, booleans, and characters. That's pretty straightforward. It's basically, you know, those are types we have in JavaScript. Types we have in lots of other languages. There's multiple integer types though. I knew about this going in, so integer is a number without a fractional component. Fractional, I guess that means like decimal, floating point. We use unsigned 32 type before. This type declaration indicates that the value it's associated with should be an unsigned integer. Signed integers type start with I instead of U. It takes up 32 bits of space. Okay. So each variant is signed or unsigned. I remember getting told in my last stream, this is just all about, the signed and the unsigned is more about handling negative values. Unsigned is for positive values. Signed can handle negative values. Let's see what it says. So they have an explicit size allocated in memory. They refer to whether it's possible for the number to be negative. In other words, when the number needs to have a sign with it, it's signed, like a minus sign. Okay. Makes sense. So each Stein variant can store some equation of numbers, where n is the number of bits the variant uses. So an I can store negative. The negative of that, I'm not sure what this exactly means. So unsigned variants can store numbers from 0 to 2 of n minus 1. Okay. 0 to 255. So unsigned 8, that's the smallest one. So we can get up to 255. So that makes sense. The I size and U size types depend on the architecture of the computer your program is running on. Okay. So this is where architecture can come in. 64-bit architecture versus 32-bit architecture. Man, this is dense. Okay. Let's break this up. I'm gonna grab this first first area here. Go back to our prompt, drop this in. Yeah, I really don't understand this. Oh, I think it's starting to storm. I just heard some thunder. Let's see. So we have our decimal, hex, octal, binary, byte types as well, it looks like. Let's see our notes here. Ah, nice, table. Okay. So, signed and unsigned. Rust offers arch-dependent integer types for I size and U size. Depends on the architecture of the computer your program is running on. Okay. So it's a specific type, I guess, for when you're going to be running on both architectures. Might not be relevant, super relevant right now. Integer literals. I don't know what an integer literal is. Let's grab this though. What do we call this? Integer types. I don't know how to do tables in Markdown. What does this look like? That looks fine. Okay. So you can write integer literals in any form. What does this mean? What is an integer literal? Okay. So these are integer literals. That's kind of a tongue twister. Decimal, hexadecimal, octal binary. Sweet, okay. Sweet, okay. So our hex values, this is mostly probably hex and decimal. Doing Bitcoin stuff. Hopefully we're not going down to the byte level. Integer overflow, uh-oh. What is this? Warning, integer overflow warning. When they throw stuff like this at you, it's kind of like, I don't even know, should I just read past this right now? I don't want to overload my mind with like a concept that's not relevant right now. So assigning a value outside of the range of your integer type can cause an overflow. We'll deal with integer overflow more later, I think. But I'm gonna put this down still. No, overflow. Ugh, Rust book. Okay. So floating point types. denoted with F, so 32, 64. Is that the only two we have? Okay. That makes sense. Minimum of 32 bits. So all floating point types are signed, understandably. Okay. That's pretty simple. I know floats. Okay, numeric operations. Addition, subtraction, multiplication, division, remainder. Yep, this is all basic programming stuff. Nothing looks different here. Modulo or remainder. Okay, I don't need to put this down. Boolean type, I don't know if I need to put this down. Boolean type in Rust has two possible values, true, false. It's denoted with bool. That's fair. Yeah, don't need to dig in to there. Whoa, put my, I didn't know you could do this. Formatted my code block, that's cool. Sweet. Oh, I should be doing this all the time. I can do this, I can find any, let's do find replace. Find any like this, replace it with this, Rust. Boom. Sweet. Oh no. I can't do that because it does it at the bottom too. Oh, whatever. Can always fix it later. Okay, cool. So floats, bools. Character type. This is our string. Rust char type is the most primitive alphabetic type. Here's some examples. Why does it look different? That Z. You can put in emojis, that's cool. Character literals with single quotes, as opposed to string literals, which use double quotes. Okay, that's good to know. Unicode Scholar value, which means you can represent a lot more than ASCII. Cool. Now into the compound types. So here. Oh, yeah, it is storming. Dang, the power doesn't flash. Okay, characters. So now into tuple, and was the other one array? Right, let's go. So tuples dealt with this type in other languages, Python. Does JavaScript even have a tuple? So tuples have fixed length. Once declared, they cannot grow or shrink in size. Comma, separated list of values inside parentheses. Okay. Different value in the tuple doesn't have to be the same. We've added optional type annotations in this example. Okay, I see. Sweet. Oops. So tuple binds in all of the values. All of that memory is allocated in one chunk, and then we destructure it. Did you grab any values? Okay. That's kind of simple. Oops. Get this in there. Sweet. How long are these notes so far? Pretty dense. Not too bad. Okay, so tuples, we bundle them together in a chunk. Okay. We can also access tuple element directly by using a period followed by the index of the value we want to use. Well, that's interesting. Is my block not ending here? What's going on? Okay. I think that's everything we need to know about tuples tonight. The array type. So, arrays, know about arrays. Okay, in Rust they have a fixed length, comma separated list with brackets. That's normal. Yep, I know when arrays are useful, or when you want to make sure you always have a fixed number of elements. An array isn't as flexible as a vector type, though a vector is similar. It's a similar collection type provided by the standard library that is allowed to grow and shrink in size. If you're unsure whether to use an array or a vector, chances are you should use a vector. Okay, that's interesting. So array is kind of this fixed size type. And the vector is the one that can grow and shrink. Okay, a lot here about arrays. Grab this first chunk. Sweet. Raise. Also initialize an array to contain the same value for each element by specifying the initial value, followed by a semicolon. An array named A will contain 5 elements that will all be set to the value 3. This is interesting. It's kind of a shorthand syntax. When are we going to want an array of like all the same numbers though? That's kind of interesting. It's highly specific. Accessing array elements, know how to do that. Invalid array, okay. Yeah, that's not very useful. Know how to access array elements. Invalid array element access. Okay. Let's just copy this block. it's not too complicated. We can't access an element outside of the range. That's it for data types. Okay, that was a lot of words for not a lot of new concepts. Definitely a handful of considerations in there, but I'll see. I mean, who knows, maybe I'm underestimating some of the things I was mentioning, but some of these seemed like very niche mentions for like this being the data types section. But yeah, let's move on to functions. This is the one I'm excited about. Everyone loves functions. Types are not that cool. Okay, so functions are prevalent in Rust code. You've already seen one of the most important ones, the main function. Okay, we know every program runs inside of the main function, or every crate, every binary. Rust uses snake case as conventional style for function and variable names, which is lowercase with underscores, so like Python. Okay, this is all very straightforward. I guess we can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Okay, interesting. So I guess since this is all bundled up like in binary, there's no... Okay, and this is also outside of the scope, so it already gets loaded in. I just thought this was a little bit weird because it's like, oh, will it be able to run this because it's not defined yet? But that's just me thinking in JavaScript. So, okay, this section, pretty straightforward. We define functions, we can call them like how you're used to calling them. So parameters, we know what parameters are. You can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the word parameter and argument interchangeably. That's kind of funny that they mention that directly, but okay, I see. So this is our, the argument is what we pass in. This is our parameter. That's pretty straightforward. Our parameters need types. Yeah, they're over explaining everything. Give me some okay. Sweet. Basics of functions, and we'll see whatever it mentions here in this chapter. So, functions. Okay. Function signatures. What is that? The type of X is specified. And function signatures? Is this... I guess this is our start parentheses. I've never heard that term. So we require type annotations. We know that. We know what kind of errors we'll get with incorrect types. I've seen that in TypeScript. Yeah, this is pretty straightforward still. Let's get into statements and expressions. So function bodies are made up of a series of statements, optionally ending in an expression. So far, the functions we covered haven't had an ending expression. So what is this? Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resultant value. Ooh, yes. This seems important. Statements and expressions. Okay. I'm gonna set this as a final breadcrumb here. I need to call it, I think. I hear this storm going crazy. And I feel like this is where we're about to get into the thick of it right here with statements and expressions. So. Got looks like right about halfway through this chapter, which is fine with me. I knew this would just be a bunch of concepts, which just trudging through and hopefully just leave the right amount of breadcrumbs for us to where once we're building these other projects, we don't need to revisit this in too much depth. We can just jump back into the notes. But yeah, that should be good for now. Solid hour session. Not a ton of new things, probably like 3 to 4 genuinely new concepts in here. A lot of this other stuff was anticipating, I would say. Lots of little, I don't know, little call-outs that I feel like the book is distracting me with these call-outs, but I don't know. We'll see. But cool. Session number 3. We'll get right back into this chapter. Close things out. Maybe we'll try and build our first little project from scratch as well. I think it's about that time. I don't want this to get too dry. So yeah, definitely join in next time and we'll keep moving our way through Rust.